Hi, my name is Oleksii Borysenko. Today we are thrilled to have Adam Lucek with us. Adam is marketing specialist on the MarkTech portfolio and innovation team and a member of Marketing AI office at Cisco. Hi, Adam.
Hey, Alexi. Thanks for having me.
Yeah, can you briefly describe which AI project you are working on and how you use Gen AI and AI technologies in your daily routine?
Sure. Yeah. So overall, I'm kind of a bit of a Gen AI specialist, I suppose. I work with a lot of the different marketing technology, specifically for our marketing organization here in Cisco. And much of what I help out with is actually understanding and applying back new technologies, which, of course, nothing's newer right now than generative AI. So much of what I do is kind of trying to figure out how these new technologies kind of operate, how it works in tandem with things like demand generation and revenue generation from a marketing and go-to-market perspective, and then also how we can start applying some of these ideas, both like internally for employee use, and then also externally, perchance for some products and applying things like that. I think I lost your audio.
Yeah, sorry.
Okay.
Yeah, if you're talking about AI agent,
Mhm.
how do you decide to use AI agent? What's the benefits compared to use just graphical user interface of different Gen AI companies?
Yeah. No, the idea of AI agents has been a really interesting one. It seems to me almost like the natural progression of tinkering around with language models and then actually applying them and integrating them into your workflow and making them kind of useful. A little bit of the assistant that people sort of imagine artificial intelligence to be, actually like being able to interact with the things that you do on a day-to-day basis, and not just be that text generation engine, but also something that can actually take an action. One of the things that I think is really important to highlight when thinking about AI agents and whatnot is that while they can be kind of packaged up into one thing, you might offer like an AI agent that can do X task or something like that. I like to think of AI agents more as an agentic design approach. And that's really taking the ideas of not just having the basic prompt and response that you usually have with language models, but applying more specific thinking, generally around having some sort of history, some sort of planning, some sort of reasoning loop along with your language model, and applying that back to your specific things, especially with stuff like function calling and tool calling. So I think it's important to not necessarily think of AI agents as something in and of themselves, but rather like for people like us who are more developer focused, a design principles as we're putting together applications that can actually use and integrate language models into our workflow.
Yeah, thanks. Yeah, I also create a few AI agent. One
Mhm.
of them connected to cybersecurity, and
Mhm.
yeah, I was surprised when I see really good output when agent can work with third-party API using retrieval augmented generation, combines this information, then analyze it. What's your outcomes to working with AI agent?
Mhm. Yeah, I mean, I think the biggest really outcomes that you're looking for with this stuff is the ability to connect that language model to some sort of API. That's really, I feel, the heart and soul of this agentic approach, or the AI agent, experience, if you want to call it that. That kind of it's all on top of the idea of function and tool calling, and the ability to get structured parsable outputs from language models. And that's really, really powerful, because generally what we're seeing is not necessarily the language model in and of itself can't necessarily take these actions. It can't call the APIs. But what it can do is it can indicate that it wants to call some API, and it can give you the arguments, or the keyword arguments, to actually fill in anything about an API call. And I think that's it's really once you kind of understand that and play around with it, the outcomes that you can drive from that are manifold. You can start applying language models to automate API calls and tapping into more of like the advanced reasoning and putting it into very weird or specific niche workflows that rely on connections to external providers or integrations within your own internal systems that are reliant on APIs. And I think this is very powerful because you can have all of that done super dynamically on the fly. All of this is trying to use that reasoning of the language model to populate the API calls. And having that really just bridges the gap between, as I was saying, language models just generating text, and then language models actually being able to take action and interface with, anything that you'd like. As you were saying, some security stuff. I've seen it, one of the big things that I've seen recently is actually people trying to have it automate things like Jira tickets, or plug into existing platforms like Asana. Because I don't think anyone really loves going through and updating all of their to-do lists in Jira stuff. So why not write a little thing, have it make an API call to Jira, populate all the stuff that you want, things like that for sure.
Yeah, thanks. I know you have tested a lot of agentic architecture. Which is your favorite one?
Yeah, I think at that point it becomes a little bit more application dependent for what you're specifically trying to do. Some of the ones that I kind of default to and the ideas that I pull, there's a few. There's like the reasoning in action, reasoning without observation, all sorts of different task specific ones, but they all rely kind of on a few core principles. The first is having some sort of planning step, or given, the user query, formulating some sort of plan. And that might be, for a lot of the very simple example ones that I have, it might be, writing out a blog post per se. And the different steps in that might be, go to the internet, search for the topic that you want to write about, compile those into notes, summarize that down, format it into a blog post, and then do some sort of reflection on that blog post to actually maybe do some editing and refining before handing it off to the final end user. So there's that first step there, the planning task there, and and then the second crucial part is that at each step of the planning phase, you want to have some sort of reflection. And these reflection-based agents are very powerful because they allow you to sort of automate the auditing or looking over, per se, of content that's actually being generated. So going back to our example of the blog post, if at one step it writes, compiles notes together, you might ask it to take a second step and actually look at those and verify whether it has all of the information necessary to answer the user's query, all the information necessary to complete the task at hand, and take sort of that time to actually think about it. And I think this is very interesting because it's modeling what we as humans actually do and think through when we're approaching different tasks, right? I'm not going to if you told me to write a blog post on, networking and routers or something like that, I'm not just going to immediately start typing. I'll formulate some sort of plan, write maybe an outline, go look, find information, and then think about it along the way, continually thinking about whether or not I have the right information, whether I need more information, or whether I'm done with that task. So I think the architecture that's actually the most powerful is kind of this idea of reflecting on what you've done. And this is especially better served when working with a lot of the super large language models, things like the Claude Opuses, GPT-4s, 4 Omnis that have more of the advanced reasoning that comes with just general scale of language models, because they're starting to be, it's not perfect. There's a few downsides to it, but they're starting to get closer and closer to being able to simulate thinking through these processes and the reasoning that you and I would do when attacking a task like that. And so automating really thought at this point and reflection can be super powerful to iteratively kind of improve the output that you're getting on this. So I would say having some sort of planning, having some sort of execution reflection, and then also if you want to extend that a little bit more on top of the planning and the execution reflection, having some sort of memory bank of what's actually been done. Because as we know, language models have no memory past what you show them. And that might be in your prompt and whatnot. Of course, you have to put together kind of all of the prior messages, and that kind of acts as, maybe the short-term memory for executing on the task. And so combining the planning, the reflection, and the memory together for one specific, outcome that you want to drive can really, iteratively allow the language model to work through tasks similar to how you and I would deliver on them and improve a lot of the output that way.
Yeah, thanks. A lot of architecture, also including reflection, consume a lot of and use a lot of tokens. Which one is more optimal for a small task for automation?
Yeah, yeah, that is the one of the big downsides of these agentic systems, especially if you're if you're using some cloud provider, maybe you're tapped into Azure or GCP and using one of their models there. Generally, it's that pay per consumption, and that consumption is either characters or tokens. And when you're doing a lot of these, it adds up a lot because generally at each step you're re-ingesting with your prompt every single other step, all the other actions that have been taken. And, the hope is we want that great output at the end there. But as we know, all of that input and input, especially when it starts to, add onto itself with no clear end, can drive a lot of cost. A few of the things that I've seen pop up to try and combat this is, especially for reflection, one of the things that I've run into is that language models aren't the best at kind of determining whether or not they've accurately finished a task. So as they are designed to do, if you give it some input, they will generate text, and they almost prefer generating text more than kind of stopping to generate text in a way, is what I've seen. And this can kind of get you into this infinite loop almost of, when it's reflecting, it might be like, oh, I want to change this. And then because at that step you've told it to reflect and see if there's anything to change, it'll just continually look for and tell you things to change, rather than stopping and being like, no, this is good. And that, of course, I've been burned a couple times of, when testing out these agentic architectures, of letting it fly, and then I come back a minute later and suddenly it's used 500,000 tokens and whatnot, and that's not great for anybody's wallet at all. But some of the measures that I've seen to actually to combat this, there's a couple different ideas. Sometimes not all of the history is necessary to be re-ingested. If you have sort of long chat histories or long strings and long plans, you might only want to dynamically insert kind of the relevant context from the agentic architecture approach at specific parts of the specific parts of where the language model is actually taking these actions. So just kind of truncating almost your message history. That would be. Also, a lot of what I've seen is kind of setting up a limit to the amount of times that you can actually run through these iterative loops. A lot of the times, I would say it's, goes back to the issue I was saying, where sometimes it doesn't know when to start, sometimes it doesn't know when to pass things off to, the next step. and setting up sort of a hard stop limit where it's like, okay, after 4 times, if you've looked at it and edited this, piece of content or worked on this step in your architecture 4 times, it's likely going to be good enough, or at some sort of quality that's passable. So just having that hard heuristic stop to be like, okay, once it hits, n number of iterations of checking this out, if it hasn't passed it off yet, just force it on to the next step. Um, so that's the first couple things that come to mind with that. Yeah.
Yeah, thanks. Yeah, when you're creating your agent for automation, how do you decide which one approach to choose, like function calling tools or state graph approach?
Yeah, this one's a really interesting one. I think because LangChain came out with LangGraph pretty early on in the game, that kind of switched up a lot of the ways of thinking about these agentic architectures, and thinking of agents per se as like a state graph machine that's connected on a graph, which to try and put that into words that aren't so graphy and mathematical, essentially just having all of the information about what your agent is doing at that point, and then allowing you to kind of go through each step along the way and either pull the relevant information out to manipulate and then put it back in, and then you can have it be a very very directed specific flow that you actually want to follow. And the opposite side of that will be kind of having just a general function calling language model. And the function calling language model approach is a lot more broad, a lot more open. It usually relies heavily on the fine tuning of the language model itself to be able to do the structured output necessary for function calling. And as such, you rely heavily on the reasoning capabilities of the language model, which generally it is the larger language models, the things like the GPT-4s, 4os, that have better reasoning capabilities of actually being able to figure out when they need to call a tool, but you're still leaving a lot of that up to the actual LLM itself. So it's goes so far as to how much you trust just the base language model to actually reason through your problem and call the right tools at the right time, if you're using just a pure language model with function calling capabilities approach for this. Which I think if you have any experience building stuff with language models, it's better to be a little bit more reliable and a little bit more predictable with them, even though language models in and of themselves aren't the most predictable things in the world. You want that repeatable experience, especially if you're building something like an external customer facing program, whether that might be like think about it like a chatbot. You wouldn't want for something very simple like a support chatbot. We've seen many things go viral on social media of people trying to buy cars for like $1 from a language model based chatbot and stuff like that. You want to have that control over it while still being able to take advantage of the unique and hyper personalized text generation capabilities of the language model. That's where I think a lot of the state graph based approaches actually really help out, because then you can give it a very, very specific direction and tell it exactly what you need to do, what you want to do, dynamically pull in whatever information is necessary and specific at the time for the process that you're trying to cover with that. And that allows you also to kind of, do very, very specific or niche flows. If you need to trigger some sort of other flow based on, what's been happening with the ongoing conversation, you can have it go down, very explicit different pathways. And it just gives you, as kind of the developer or the systems architect, something like that, much more control over it, while still being able to take advantage of the text generation capabilities. Some of the different kind of examples of what I've worked on with stuff like this is not necessarily is because you can still use the function calling capabilities, and it is encouraged to use the function calling capabilities. But what you might be doing along the way is instead having it go down a flow, and then when it calls a function, you can either not execute on that function at that point if it's not ready for that, and then kick it back. Having some sort of verification step where it can kick back to different parts in your flow graph, fail safes and backups like that. It just makes a lot of these systems a lot more reliable.
Yeah, Adam, can you share a few AI agents that you using or created that use both approach? I mean, tool function calling and state agent graph.
Hmm. Hmm. Yeah, yeah. I think the just pure function calling part, what I've done is actually been more interested in how do you kind of optimize the costs. So using the smaller language models, I mean, small in this case is relative. So a lot of the times what I've done is used and put together something like GPT 3.5 into more of a function calling approach, because it does have function calling capabilities, but for some reason in the chat GPT interface, they don't actually have that kind of enabled. So I built my own to be able to use the smaller language model, minimize a lot of the costs that I would be paying, but also being able to give it kind of the custom tools. And so that approach is more of the, assistant, I would say, approach, having it just giving it a bunch of things that it can do and call for you, whether that's like, searching the web for me or generating a picture with like, my own specific model or whatnot, or even connecting it back to something maybe like Notion to put together, very specific notes, or maybe create some sort of plan based on the conversation that I'm having with it, while doing some sort of research or whatnot. And when I need that sort of very loose and open stuff where I'm not, 100% sure of the task at hand of what I want to do, but I want to keep it open, that's where I'll use that. Some of the other tools that I've built, one of them was kind of funny. I built one that's more the state graph approach, but focused around actually generating YouTube titles. So I've made it specifically designed in the state graph approach to do different things at different steps. So what I'll have is the first step of the graph is actually pulling in the relevant data that I want to analyze from the YouTube API. And this is where the state graph approach also becomes really cool, because you don't necessarily need to do a language model call at each step of the progress, or at each step of the graph. So my first node might be something like pulling in the relevant data that I want to analyze. So to actually set up this flow, I had it analyze some big YouTubers, things like Mr. Beast or Ludwig or something like that, the many millions of subs who have obviously figured out the YouTube algorithm in some way, pull in their titles, and then taking that data, what I can do is pop it back to the graph and hop on to the next step. And then the next step is actually generating some report. And to do the report generation, that's where I then pull in the language model at that part of the graph. So then I can pass that all off to the LLM of my choice. The cool part about this is that, this is, you might think of this as like a function or like a tool per se, generating this report. You don't actually need to use the explicit function calling capabilities with a graph-based approach. So I actually use just local language models for that part of it specifically. Don't even have to. I can run it all on my computer. Don't have to pay to any service or whatnot for that. And I can just plug it right in or mix and match any model. So at that point, what I do is pass it off to your local language model of choice for the week, whichever is the best one that's come out recently, and then have it write a report. And then the cool part is that then I've got the report. I have all the information. This is all stored in the state, and I can figure out what I want to do with that kind of dynamically. So at this point, what you could do is actually use a language model to figure out the next step of your graph, which I've used this a few times to determine which pathways I want to go down, which is pretty cool. So like I could have it, either go to like a reflection step, or I could have it pass. And so what I actually do is I have it go through just a general reflection step. And what it'll do is it'll look at the report, it'll look at all of the data that I pulled from the YouTube API, and then it'll make a decision. And the decision at that point will be, have I, covered everything? Is my report good and ready to actually pass off? And then this is where you can take advantage of also the structured output. And so I have it output a little bit of an explanation as to why it thinks it's either good or bad, and then a decision. And the decision is just, yes, it's good, or no, or just yes and no. And then from that, you can then set up your if else statements and be like, okay, if it's good to go, we pass it off to the next part of the graph. If not, then you can insert those instructions back in. And this is, of course, using that reflection step along with generating additional instructions to iteratively improve on a task. But what I have then is that once it's analyzed the data and given me this report, I'll pass it off to kind of the next node. And the next node, of course, is the YouTube title generator. And so what I'll do is I'll input some sort of new topic, whether that's any sort of topic of your choosing, and it'll look at the report that it's generated about how to make good titles based on these popular YouTubers who are successful, and then your new topic, and kind of mash them together and create some new ideas. And then at this point also, I inserted in another reflection step. So I have it look at it and be like, okay, are these good titles? One of the things that I've realized is that language models tend to kind of give you a lot of the same ideas, the same titles, at least for YouTube titles. Probably not a lot of people have ran into this specific issue, but one of the observations that I've made when trying to do a little bit of brainstorming. So I have it iteratively go through and reflect, give it additional instructions if it wants to change any of the titles and stuff like that. And this is all possible because I'm keeping track of all of these points within the state graph. And because of that, I can dynamically insert whatever LLM I want to do, and also dynamically change what pathing along my total flow I want. So then at the end, once it's all coming out to me, it will have gone through all of these steps, reflected on it iteratively, and then passed off my final output.
Yeah, I have some. We definitely want to use it for Cisco DevNet channel as well. Yeah, by the way, did you utilize video transcription as well, or just a title?
Yeah. So for this one specifically, it was just the titles, but I have actually used some transcription parts. And this is also where this kind of state graph approach, or just general agentic design thinking, can come into play. One of the funny things that I was actually tinkering around with is taking like informational YouTube videos, ones that are maybe more lecture focused, or specific to what I might be interested in doing. And then you can dynamically insert whatever language model at each step, or even other machine learning model at each step along the way for these state graphs. So my first node was inserting whatever YouTube video I wanted to analyze, and grabbing out the audio file and all of the relevant information that I want from the YouTube API. And then the second step is actually passing it off to the first machine learning model, which is Whisper, the text or the audio to text transcription model, and passing it off through that. So then I generate dynamically the transcriptions, because if you've ever looked at YouTube transcriptions, they are somewhat lacking. They need to update whatever auto-generated captions they've got there for sure. There's some late grade stuff that could really help it. So I insert all that into Whisper to generate some transcription. And then from that transcription, I also like employing, similar to what I was doing with the YouTube titles, creating a report on the different nuances, the techniques, the flow, things like that, and then applying it to a new idea. So one of the things that I actually did as a small demonstration was using this to take in a video, some informational video, transcribe the text, write up a report on the different techniques, the flow, the words used, how it was, and then apply that and create me a full script for another presentation. And so, it was a little bit of tweaking at the end, but for the demonstration of this, it was pretty cool because it was able to take all of that information. And because I had it all structured out in this agentic approach, it did every step along the way and reflected a little bit on it, and also kept it all in memory, and was able to apply it to that last thing there. So that was a bit of a fun one with the transcription part of it, actually.
Yeah. Thanks. You mentioned about small language models. Which one do you use for this type of tasks?
Yeah. I mean, I am model agnostic, I think might be the best way of putting it. Whatever whatever the latest greatest one is, that's the one that I want to be using, right? So obviously you're going to get the best performance, I would say, across the board for general tasks from the more large providers, the things like GPT-4, 4 Omni, Claude Opus, the newer offerings like Mistral Large 2, Llama 405B, stuff like that. But one of the things that I actually find is that generally those super large models are a bit overkill, honestly, because they're generalized models. They're great at everything. It's not necessarily, you're not taking advantage of everything all at once, right? So you can save a lot of money. You can save a lot of compute by narrowing stuff down into smaller language models. And so generally what I'll do is use the state graph agentic approach so that I can make sure that it's following the right path along the process and output that I want it to get, but inserting in sort of the latest, greatest, smallest model, which recently I've been trying out the Gemma 2s from Google, which are really good, and Llama 3.1, which is really competitive, and stuff like that. And especially at a smaller parameter size, like 8B or 8 billion parameters, 7 billion parameters, those can usually run on kind of like your everyday, recent MacBook or Lenovo laptop pretty decently. So that's great ways to get started prototyping, iterating with stuff like this. Some of the future states that I've started to see is actually creating and tuning models and small language models for downstream specific tasks and agentic approaches. We've seen stuff like Salesforce right now is starting to create a bunch of SLMs, or small language models, which small is relative in this whole term of machine learning and whatnot, but like around 1-2 billion parameters that are hyper tuned just for the function calling aspect of it. And this can be great because it can take in some sort of user intent and then convert that intent plus a little bit of text into your super specific function that you want to call, or path that you want to go down if you're doing the function calling versus state graph approach. And I think that's one of the cool ways of doing it. And then the second part that I've started to see too is a lot of the times with function calling and agentic approaches, you might a lot of people are starting to apply these with things like customer support chatbots or just general chatbots. And when you're creating these chatbots, you can get some really good training data from them. So a few things that I've seen kind of externally and around for people like hyper focused on creating chatbots is actually starting out with large language models, the super large ones, to sort of get things going and get that good user data and feedback from people actually using it. And then once you have the actual, a log of transcriptions from whatever chatbot, whether it be support or whatever, you can use that as training data, or like multi-step, multi-query training data to better hyper focus a smaller language model onto that task. And this is one of the things that even OpenAI a while ago has kind of identified, is that if you take the outputs of super large language models and then use that as training data for smaller language models to fine tune them on that, you can generally get the same outputs and the same quality of output from the smaller language model up to the performance of the larger one. But of course, you need all of that data. However, when you're making these agentic systems, a lot of times people track exactly what's going on where, different user intents, if it's chat based, the chat logs and stuff like that. And what I've started to see is people start to focus on splitting up these into different splitting up these parts into different models, super small, hyper specific models, and then you can run them, on edge devices. You can run them with a lot less compute, and it can still give you the same quality and understanding, but for your hyper focused use case. And of course, this is big optimization because then you don't have to rely on just the generality of a super, super large language model.
Yeah. Thanks for mentioning about this. From our community, we know that at the beginning of the story, like 2 years ago, some of them also try to deploy language models inside of Cisco devices like Catalyst, etc. So try to create their own so-called private assistant locally. Which AI agent that can work with Cisco solution or API, and you can highlight for our audience?
Yeah. So I don't necessarily work super specific with the products themselves, but some of the cool parts and ideas of like agentic approaches are starting to be applied. We've seen things like the security assistant or firewall assistant, I believe it might have been, actually start to be implemented. And some of the things that are super cool there is that really democratizes the ability for someone to come in and actually set up and interface with a Cisco device. Me myself, I don't have a networking or IT background specifically, so when I hear of stuff like this makes complete sense to me. And because looking at kind of some of the dashboards, as someone who's not super specifically in the networking industry, it can get super confusing. I barely know how to set up my router half the time, just at home and whatnot. But being able to kind of democratize this and converting natural language into actions that can do something like set up a switch, set up a router, set up some sort of firewall based restrictions, or even having putting in what you want to change about it, whether it's like role-based access controls. So like I want to set up for this segment of people to be able to access this, and then just converting that natural language query into some sort of function call and having it be an agentic approach to setting up these more niche, I mean, not niche, but at least to me, it's a little bit more niche devices, seems like a no-brainer. Because then anybody can use our products and anybody can approach our products. It doesn't need to be, something that's scary and specialized, and that you might be wary of actually digging into, because that through some assistant, you don't have to be the super domain expert on all of this stuff to actually be able to configure them. Some of the other cool stuff that I've seen too is, especially with like WebEx and the different AI assistants within WebEx, of actually summarizing different collaboration meetings, being able to take away actionable insights from them, and then also in the Teams chat interface of being able to kind of give me a summary of what happened over the last week. I mean, that one's great. I was just gone for a full week, and for everyone who knows, being gone for a week, it seems like the whole world has changed by the time you've gotten back to work. So being able to just go through all of my specific chat rooms and be like, what did I miss? What's the super things? Did anyone mention my name even? Like, am I missing something that I should be doing? And it being able to kind of summarize and give me those things are some of the cool things that I think we're really doing, and I think is a good direction for making a lot of our products and our services a lot more accessible to a wider audience.
Yeah, thanks. You also can share your screen, and do you want to share something?
Let's see. Let me pull up here one specific example. This one might be. Here we go. Yeah. Sorry, I should have pulled this up a little bit earlier. Here we go. This is kind of getting into the art of the possible. Let's see. Okay. All right. Is my screen up and running now?
Yeah, I see it.
Great. Yeah. So some of the things that a lot of people are starting to think of is if you have these different agents or these different function calling capabilities, how do you actually start to string them together into more advanced workflows? So a few of the ones that I've seen are, different agent supervisor approaches of actually having some sort of language model that sits at the top and just purely do the supervision, so delegating tasks out almost like a manager would. Some of the others are also taking that one step further and having it be like an agent supervisor team of having one agent at the top and having multiple agents like within that all report back to kind of your initial team. And then right here in front of us, what I've pulled up is actually the multi-agent collaboration planner kind of framework. And this one's interesting because what it is almost simulating the individual contributors' teamwork along the way. So it'll, for this specific one, I wanted to put together an agent that'll, plan me out my weekend and find anything fun to do. And so what it does is I've got one language model that's equipped purely with different weather-based tools, one that is equipped with actually searching over event databases, and then one that can actually search the web. And what it'll do is it'll take my user queries. So, I'm over here and in North Carolina, so I might be like, what can I do this weekend in North Carolina? And what's the weather gonna be like? And if there's some fun stuff to do, like where might I want to park? And so think about this as kind of like, your manager being like, you've got this task to do, but everyone on your team is kind of specialized down into this. So of course, my weather agent would be like, okay, we don't have the weather data, but we need to get that. So let me go look up the weather in North Carolina. And so it'll get that. And then what it'll do is it'll pass that off then to the other specialist. So, the weather agent's just here for the weather. It doesn't know nothing about events. So it'll pass it off to the events agent. And then the events agent might be like, okay, we've got the weather. That's cool. I can see that. Because, of course, this weather agent, and when you're sending work over to your colleague, you want to give them kind of all of what you've done and have them understand what you've done to contribute to the end goal. So it passes it all off. The events agent's like, okay, we've got the weather, but we're missing the events. Where's the events on this? So it might go and look and be like, okay, let's go look for some events. And it'll search the databases, find some maybe for a specific area that I want. And then it'll be like, great, I did my piece. Let me pass it off now. And so then that'll go over to this web search agent here. And the web search agent then would be like, okay, we've got the weather, we have the events. The user, me, Adam, was asking what's fun stuff to do, what's the weather in North Carolina, but also for the events, where can I park? We've got the events, we've got the weather. I don't see anywhere to park, right? So then that's where this web search could kind of act as the fail safe and actually send out kind of some web queries, find relevant data that's very dynamic based on what it knows the other agents have done. So if the events agent is like, okay, there's a cool, concert in Asheville, North Carolina at, this time and this amphitheater or something like that, it might look at that and be like, all right, I should probably find parking for, Asheville amphitheater or something like that. And it can do that. Then it passes all the work back off to, the weather agent. And so they're all collaborating on this problem. And then the cool part is that at any step of the way, any one of these people could be like, okay, we've got enough information. Let's actually send it off back up to me. So usually what I'd see is it would go through, and then unless it wanted to actually change or edit something, it would take all of that information. One of them would write me up a cool report and then pass it right back off up to me. And you can do this. You can do this in two ways. Right now, I had it strictly set up just to go through, step by step in that state graph approach. But you could also start thinking of it a little bit loosely with actually asynchronous calls to language models and having things kind of go up and over all sorts of ways all at once. So I think this is a cool kind of hypothetical down the line of thinking about stringing together the reasoning and function calling capabilities and into like super advanced agentic approaches here.
Yeah, thanks. I see that you use agent-to-agent interaction here.
Mm-hmm.
Which technology did you utilize?
Yeah, for this one, you could kind of write this all yourself if you wanted with a bunch of if else statements, but LangChain's LangGraph package actually makes it really easy to start putting together and compiling a lot of these agents. So usually that's my go-to when putting it together, because they've made it specifically. They've designed the package specifically to set up these state graph approaches, which just expedites the process a whole lot.
Yeah, thanks. Yeah, my last but not least question: which resources can you recommend for improving skills?
Yeah. So, I mean, there's plenty, I would say, of just general resources out there online now. People are more than willing to share a lot of things. There's some good, so I would say, search around for, industry videos. A lot of what I do is look at different videos of people explaining what they've been doing with language models, building different agents and checking them out. I know there's some specific pathways, like Andrew Ng's been made, like deep learning.ai, I think it's called, that has more specific pathways. And then honestly, a lot of what I use to kind of boost my knowledge are language models themselves. I found that if you have kind of a specific area of interest that you want to learn about, especially if it's code based, which language models excel at right off the bat, I'll pop it into your favorite chat interface of the day, whether that's Claude, ChatGPT, any one of those, whatever, and just start asking about how you might want to set these up and some of like the example code, maybe even putting in blogs. I know LangChain has a lot of really, really good blogs and videos also about from very basic to super advanced agentic systems. If you're just getting into making agents and whatnot, I would definitely check out LangChain's resources. That's honestly where I started with a lot of this stuff too. And that stuff makes it real easy to get into.
Yeah, thanks. As I know, you also create a lot of content and you have your own YouTube channel. We will share a link on it in comments. Am I right?
Of course. I do go into a lot of different agentic resources, both from the bottom of like thinking about what an AI agent is, all the way up to, going over, I've got a full video dedicated on this multi-agent collab planner here, among other all sorts of anything language model, AI, machine learning related stuff. So yeah, didn't want to shout myself out right away, but I've got plenty of videos that are hyper specific around this stuff as well, if that interests anyone. And all of the code and whatnot that I go over is of course always going to be free and available for people to check out. So more than happy to drop that down as a resource if people are interested in getting started building with this stuff.
Yeah. Many thanks, Adam, for sharing this information. It was really helpful for us and for our community.
Of course. Yeah. There's one question I'm seeing actually in the chat from LinkedIn from Matt Rogers.
Yeah,
He
sure.
says, are
Understood.
there any strategies for error recovery when an LLM fails to use tools and functions properly? For instance, when responses don't have proper JSON. Yeah, so the way that I've seen a lot of this be approached is kind of similar to that reflection step. If you do something like a error catch and then kick it back to regenerate, that can usually help out. I know some of the approaches for getting structured output from non-fine-tuned for structured output approaches actually just do this of just having it reiterate itself until it actually does valid JSON outputs, which you can kind of validate with maybe like a Pydantic data model or something like that. So just reiteratively doing it over and over until it works sometimes works.
Yeah. Thanks for addressing this question, and thanks again for your time.
Of course.